Hello. In this video, I am going to discuss about the question number 58 from part C from CSIR-NET-June 2019. So let's start the question. So the question is, an operator A is given in basis 1001 and you have to identify the another matrix in different bases. So this question is from the similarity transformation question. So this question is, the topic is similarity transformation. So I will give some detail about the similarity transformation. So the given matrix and the matrix you have to find out in different bases. Both the matrix is known as the similar matrix and they represent the same linear map under two different bases. Okay, so we can convert the given matrix into the matrix B in bases 1 by root 2, 1, 1 and 1 by root 2, 1 minus 1 using similarity transformation or using a matrix P which is known as the invertible matrix. Okay, so we will do this question by using two methods. So one method is, there is a properties of similar matrix. So the properties are, first property is that the determinant of A is equal to determinant of B. And the second property is, both the matrix have as same eigenvalue. And the third property is, trace will be same. And the fourth property is that the transform matrix should be diagonal matrix. Okay, so using these four properties, we will identify which matrix in the basis of 1 by root 2, 1, 1 or 1 by root 2, 1 minus 1. So the diagonal matrix in the given options, the diagonal matrix is option 1 and option 2. So the 3 and 4 option will be discarded. Okay, now from 1 and 2, the trace of matrix 1 is equal to the trace of matrix 2. So we cannot identify using the property related to trace. Okay, so we will move towards the eigenvalue property. So first we will find out the eigenvalue of the 2, 1, 1, 2 matrix. To find out the eigenvalue, 2 minus lambda, 1, 1, 2 minus lambda. Okay. Okay. So 2 minus lambda whole square minus 1 will be equal to 0. 2 minus lambda will be equal to plus minus 1. So from here, lambda will be equal to 2 plus minus 1. So you will get 3, 1. So the diagonal matrix has its eigenvalue as its diagonal elements. Okay. So the question 2 will be, the option 2 will be correct because it has 3 and 1. So the diagonal matrix has diagonal element as its eigenvalue. So now let's move towards the second method. So this is the first method. Now the second method. So a matrix is given to you 2 1 1 2 in the bases 1 0 0 1 1 0 0 1. You have to find out 1 0 0 1, and you have to find out another matrix B using a matrix A in the basis 1 by root 2 1 1 1 by root 2 1 minus 1. Okay, so we will create an invertible matrix P using these vectors, these bases. So we can write it as x1 comma x2 is the x1 comma x2 is the invertible matrix, and that will be 1 by root 2 1 1 1 minus 1. So now you can find out matrix B using the formula P inverse AP. P, you know, P is 1 by root 2 1 1 1 minus 1. Now you have to find out P inverse. So you can see that P into P transpose is equal to identity. Okay, so it's a diagonal, it's a orthogonal matrix. So if you find out the transpose of P, the transpose of the given P will be, in the transpose you convert row into column. So 1 1, if you convert this row into column, you will get 1 1, and 1, the second row into column, second column, you will get 1 minus 1. So the P is equal to P dash. If you multiply these two matrices, you will get identity. So from here you can say that P is equal to P inverse. There are other methods also. You can find out P inverse using adjoint of P upon determinant of P. You can also find out P inverse using this method if you don't know this. Okay, now you have P inverse, you have A, you have P, find out B. So B will be, you know P inverse. P inverse is 1 by root 2 1 1 1 minus 1. A is 2 1 1 2, and P is 1 by root 2 is there. So I'm writing here 1 by root 2 1 1 1 minus 1. Now you will multiply this. You will get, how you multiply two matrix? So I'm multiplying first this matrix and this matrix. So how we will multiply two matrix? This first element will multiply this. You can multiply this row with this column, this row with this column, and the second row with first column, second row with second column. So first row with first column. So 2 into 1 is 2, and 1 into 1 is 1 plus. First row with second column, 2 into minus 1, and then second row with first column, 1 plus 2. Here you will get 1 minus 2. Okay, now we will multiply this. What you will get? So this is 3, 1 into 3, 3, 1 into 3 plus 3, 1 into 1. So this is 1. So 1 into 1 is 1 into 1 is 1, and 1 into minus 1 is minus 1. 1 into this will be 3, and minus 1 into 3 is minus 3. 1 into 1 is 1, and this will be minus 1 into minus 1 is plus 1. So the B matrix will be 1 by 2 6 0 0 2. Divide by 2 each element of the matrix, you will get 3 0 0 1. So this is the answer. So I have discussed two methods. One method, so I am summarizing the whole concept. So I have done this I have calculated the answer of this question using two methods. First one using the properties of similar matrix, and the second using the formula B is equal to this formula, B is equal to P inverse AP, where P is an invertible matrix, and in P you can calculate, or you can write in terms of the given basis, in which you have to find out the matrix. Okay, and P inverse you can calculate by any method, by using the adjoint P by mod determinant of P, or by this method. Then multiply all three matrices, you will get the answer. Okay, I hope this question will be clear to you. It's a very important question. Thank you for watching. If you like my video, please press the thumb icon, subscribe and hit the bell icon, and please share with your friend to motivate me. Thank you for watching.